So we have a value of a car is depreciating according to this model here. What does this model tell us? And then we'll try to solve the equation. Notice the base here. So this is related to the formula that the value of the car is going to be equal to its present value times 1 plus the rate of change raised to the power t. Now they're claiming that 1 plus is 0.82. Since this is less than 1, that tells me my R is negative, which makes sense because this is a depreciation. So the question is, what would I take away from 1 to get 0.82? Well, to figure that out, just take 0.82 away from 1, and you get 0.18, which is 18%. So what I can see here is this is an equation for a car that depreciates by 18% per year. Okay, because that is under 1. How much under 1? 18% under 1. That means we lose 18%, we keep 82% of the value. The original value of the car was $11,000. Now we want to know, when will the value of the car reach 5,000? So we take our equation, 11,000 times that 0.82 to the power t, and we set that equal to 5,000, and we solve. This is like some of the other problems we've done before. It was a problem similar to this in the lesson. To solve this, I have to get rid of the multiple first. So I would divide by 11,000. Divide by 11. Where do those 8s keep coming from? I'm stacking my zeros instead of writing them next to each other. There we go. A number divided by itself is 1, leaving just the 0.82 to the t behind. On the other side, at the least I can do here is reduce, divide by 1,000 top and bottom, and call it 5/11ths. If I make this a decimal, it's going to be a funky decimal, and so I'd have to round it. So I'm just going to leave it as a fraction. If you're not clear what I mean by that, let's take a look at the calculator. If I take 5 divided by 11, it's 0.45454545. So I'd have to round it somewhere. So I could either deal with rounding or just not leave it as a fraction. I'm going to leave the fraction. Once we get the base with the power isolated, that's where the log jumps in. So then I take the log of each side. This side has a 0.82 to the t. This one has just a 5/11ths. On this side here, that t pops out front. That's a property of logarithms, super important. So I get t times this log of 0.82. Other side, that log of 5/11ths is still chilling. And then to get t alone, I have to get rid of this multiplication by dividing. So I'm going to divide this side by the log of 0.82, divide that side by the log of 0.82. Now on this side here, I have a number divided by itself, which is 1. So that tells me t equals this fraction right here with the logs. We cannot cancel the word log. That's highly illegal. We just have to type it as is. So we're going to type it and then check it on our equation. Calculator. One shot, we type log of 5/11, close parentheses, in the right spot. Divide by log of our base, 0.82, close parentheses. So we don't have to do these logs separately. Modern calculators, you do it in one shot. We get, it's going to take about 3.973 years to 3 decimal places. This asked for, to the nearest 10th, 1 decimal place. So I would say the 7 rounds the 9 up. So this would be 4.0. We should check. To check, go to the original equation, which said take 11,000 times the base 0.82 raised to the power how many years? We think it's about 4 years. And then I should get about 5,000 for the answer. Now this is a little less than 5,000 because we've gone beyond the number of years we had here. If I type all those decimal places in, I'll get closer to 5,000. But the program asked me to go to 1 decimal place. That to 1 decimal place is 4.0, which is the same as 4. Doesn't change much. So I get about 4 years. Check.